Let's take a second to just review what we know so far. We know that when we have a set of points where every input goes to one output, that we have ourselves a function. And we know that not all functions have patterns, but in this particular case, as we're looking at this function, we can see that there is definitely a linear pattern to this, meaning if I were to connect all of the points with a line, this would create what we call a linear function. So let's just do that. Let's make a line that goes through these points. And so when I draw this linear function, and I'm going to keep as steady of a hand as I can, we can see that there's the line that goes through the point. Now, we also know about the slope of this line. We've talked at great length about the slope. So I know that if I do a rise over run between one point and another point, my rise here would be +1 and my run would be +3. So the slope of this function is positive 1/3. We also know that I can do a rise over run between any 2 points, and I will get the same ratio. So for example, if I wanted to go from this point here that I'm highlighting in green to this point here, I'm going to go up 2 plus 2, and I'm going to go over 6. So my rise over run is equal to 2 over 6, which of course is equal to 1/3. So we have this rise over run. But what we don't know is what is the connection between the inputs and outputs. What is that function? That's what we want to know. What is that function that creates this linear equation? And in order to do that, we have to do a little bit more pencil and paper work. Now, we know that to find the slope formula, to find the slope between any 2 given points is going to be, if I'm given 2 points, x1, y1, and x2, y2, that the slope can be found by taking y2 minus y1 over x2 minus x1. And so if I do the slope on, we know that the slope is going to be 1/3. So if I take one point on this graph, and it doesn't matter which point I take, but I'm going to use this point right here, which is the point 6, -2. I know that if I have that point right there and some other generic point, and I'm going to put my generic point right here. I have no idea what that point is, so I'm just going to call it xy. It's some generic point xy. But what I know is that if I want to figure out the relationship between xy and 6, -2, that I can simply use my slope formula. And I can take y minus a -2 divided by x minus 6. Well, that's the slope formula. And I know that the slope is going to be equal to 1/3. So what we have right now is we have a connection between the slope, which is 1/3, the point, which is 6, -2, and some other generic point, which is xy. And if I do a little bit of algebraic work on this equation, so I'm going to multiply both sides by x minus 6, which will eliminate the x minus 6 here, then I end up getting y minus a -2 is equal to 1/3 times x minus 6. Or I can rewrite this as y plus 2 equals 1/3 times x minus 6. And this is going to be my linear function that not only relates x and y together, but it graphs this line right here that we see. Let's put this to the test. So I jump over to Desmos and I see here are those points that I've just defined. And let's put in that function that we just saw. The function, once again, is going to be y plus 2 equals 1/3 times x minus 6. So y plus 2 equals 1/3 times x minus 6. And we see that that is, in fact, the line that passes through these points.